charger?
Hello and welcome to today's e-learning assignment. We will be looking at the quotient rule today, but before we get to that, we'll take a review and look at what we learned yesterday and see how that applies to the quotient rule. Last week we looked at the product rule. The product rule states that if you have two numbers that we can rewrite them and say, okay, it can be written as 7 times 6 times p to the second. And we found that there was a shortcut to where we could simply add the exponents if they have the same base. So what we did was we did 7 times 6 was 42. P stayed the same. 1 plus 2 is 3. And again, this is when you're multiplying numbers that have the same base. So we end up with 42p to the third. And the reason that works is because you can work it out to where it would have been 7 times 6 times p times p times p. And then we end up with 42p to the third. Looking at number 2, we can still continue to do that same thing. P is our base. We're going to keep it. And we're going to add the exponents because we're multiplying here. So 4 plus 2 is 6. So if you add when you're multiplying bases that have the same exponent, you're probably going to subtract when you divide. So let's take a look at that for a second. So we have 2r over 8r to the fourth. Now it's kind of written like a fraction, but remember fractions are just divisions. So we can reduce 2 over 8 to 1 over 4 because they're both divisible by 2. Now r is not just simply r, it's r to the first. You're always going to take the base with the smallest exponent and subtract it from the base that has the bigger exponent. So we're going to move r to the first down here, and we're just going to subtract the base. So r is going to stay on the bottom, and then 4 minus 1 is 3. So we end up with 1 over 4 r to the third. And that's what you're going to do every single time. And the reason this works is we could have written this out like 2r over 8r times r times r times r. And what these cancel each other out. And you're left with 2 over 8 reduces to 1/4. And then there's 1, 2, 3 r's. And either way, you get the same answer. Now, looking at number 4, this time 6 over 3 can reduce to 2 over 1. And then you'll notice that these r to the third, r to the third. Well, it doesn't matter which one you move because they're the same. So if we minus 3 from both sides, we end up with these canceling each other out. So you're simply left with 2 over 1, which can reduce to 2. Looking at number 5, you have 8x squared over x to the fourth. Now, 8 is simply going to stay the same because there's nothing to do with it. We're going to move this x to the second to the bottom and subtract it from the x to the fourth. So x to the fourth becomes x to the second. And this is your completed answer. Again, the reason this works is because 8 times x over x. What happens is these cancel each other out. You're left with 8 over x squared. Again, same answer, but a shortcut is to use subtraction for the quotient rule. Now, looking at 4 over 7, it doesn't reduce, so we're simply going to leave it as 4 over 7. And this time, the exponent on the bottom is smaller, so we're going to subtract the 3 from the top. Well, r stays on top. 4 minus 3 is 1. Remember that we don't have to write this exponent because it's a 1. We assume that it's there already. So this problem can be rewritten as 4r over 7. Number 7. This time there are no numbers. We're going to move this to the top. And so we're going to subtract. We're going to keep the base the same. N to the first. And then you'll notice how this cancels out and there's nothing down there on the bottom. We always assume that's the number 1. And so anything written over the number 1 can be just written as itself. So n to the first is simply going to be n to the first. But remember, we don't have to write the exponent. So the answer you're looking for is simply n. Number 8. Again, 5 over 8 does not reduce. And this time, n to the third are going to cancel each other out. And so you're just simply left with 5/8. Number 9, 3m cubed over 2m. 3 and 2 do not reduce, so just leave them as 3 and 2. This is a 1. We move it to the top. 3 minus 1 makes this m to the second, and your final answer is 3m to the second over 2. Looking at number 10, you have 2 over 2, which can reduce to 1 over 1. We're going to move this to the top because n to the second is smaller than n to the fourth. N stays on top, and 4 minus 2 is 2. Anything written over 1 can be written as itself, so this will be rewritten as n squared. Remember, you do not have to write the number 1 in front of a variable, so the answer you're looking for is simply n squared. We assume that the 1 is already there. Looking at number 11, again we have 2 over 2, so this can reduce to 1 over 1. And this time the x on the top is smaller than the x on the bottom, so x to the third is going to become x to the second because 3 minus 1 is 2. And then that is your final answer. You'll probably see it written as 1 over x to the second because it's not necessary to write the 1 in front of the variable. Number 12, this time 2/4 reduces to 1/2. We're going to move the p to the top because 2 is smaller than 3. We keep the p, and then 3 minus 2 is 1. Now, you'll probably see this written as p over 2 because you don't have to write the number 1 in front of a variable, and you never have to write the number 1 as an exponent. We assume that they are both automatically 1s. So you'll probably see this as the answer of p over 2. Your assignment today is to complete 10 multiple choice problems for the quotient rule on Canvas. You'll have up to 3 attempts. Again, it's multiple choice. And so if we look at number 13, and I'll do this one for you, that means you'll only have 9 problems to do. 4 over 2 reduces to 2 over 1. K squared is bigger than k to the first, so k stays on top. 2 minus 1 is 1. You would probably see this written as anything written over 1 is simply going to be itself. And remember, we don't have to write the exponent to the 1. So this 1 and this 1 is not necessarily right. So the answer you're looking for is 2k. And if you look, D is 2k. Again, you'll have up to 3 attempts. If you have any questions, please email me at eSutherland@acsc.net.